Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 4-1 in the SavvasRealize Algebra 2 textbook. So the focus of this example is to identify inverse variation. So the first thing I want to do is actually define what that means. Alright, so I have a definition here in this nice blue box. Inverse variation is a relationship between two variables so that as one variable increases, the other one decreases proportionally. Alright, so we're looking for a common relationship. And so in order to tell if you have a relationship that represents an inverse variation, what you do is you multiply together the x and y values for each ordered pair, and you see if that product is constant. Okay, we usually use the letter K and call that the proportionality constant. So let's go ahead and let's test out some of these. So what I'm going to do is I'm going to start multiplying together the columns of these tables. So here 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 4 times 3 is 12. Don't get your hopes up and stop here. Keep going to make sure it's all over here. All right. So 2 times 6 is 12 and 12 times 1 is 12. So here, because each of my products matched, I do have an inversely proportionate set of data. All right. And again, because you're looking for all those 12s. Now that 12 is called the proportionality constant, just so you know. So now let's try this one. Better make sure I have my handy dandy calculator ready for this. So 1 times 20 is 20. And 2 times 17 is 34. Now I could stop here and I could say, because those numbers don't match. Now, for the sake of making these notes look pretty, I'll keep multiplying just to show you. Okay. So there we are. So no, these are all different. All right. So that is not a inverse variation, whereas these are all the same. And that's what made them proportionate there. So then Savvas turns nice and they actually give you like a little box to fill stuff out with. So that's kind of cool. So on this one, 1 times 25.5 is 25.5. 12.75 times 2 is also 25.5. 8.5 times 3 also gets me that value. 5 times 5.10. There we are. 6 times 4.25. Alright, so if you notice, all these values that we're getting here are all the same. So yes, this is an inverse variation. And again, it's because they all have that same value when I multiply. Now down here below, right, I'm doing this again. Of course they give you like decimals and stuff, so it's a pain in the neck to multiply by, but it's fine. That's what calculators are for, right? And again, I could just do these first two boxes and I could be like, nope, not today. All right, so you can stop as soon as you don't have that same number. Okay. So there we have it. I'm just going to fill out the rest of this table here because I'm a little crazy that way. But that's how we find inverse variation and whether it is inversely variant. Now, one thing you guys will find is that we will then use that number and call it our proportionality constant and create an equation from it. And so that'll be our next example, is how to create the equation. So here we're just identifying if it exists. Next up is creating the equation. So until next time.